All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over the PowerPoints for the Farrell C# text, Microsoft Visual C# 2015, an Introduction to Object-Oriented Programming. And I've been going over all the PowerPoints, and for most of the last several chapters, I've also been writing some code. This is the first time I'm trying to do a lecture from Rankin, and as you can see, it looks like my background's a little bit different. That might be something that I can reset, but I don't know how to do it. So I'm going to go with what I have. So Chapter 11 is on exception handling. The first thing to realize about exception handling is an exception in the world of computers, in the world of information technology, is not a good thing. And the reason I say that, and I've given this example before, is if you are let's suppose that you and your spouse have just had a child, and for the first time you're taking your child for a walk in a stroller, and a stranger comes by, looks at the child and said, "Wow, what an exceptional child." Okay, or if your kid appears to be very bright at a young age, or at any age, you might hear, "What an exceptional child." That's typically thought of as a good thing. However, in the world of information technology, exceptions are thought of being as exceptions to the rule, so they're not a good thing. So in this chapter, we learn about exceptions, the associated exception class, generating system exceptions. All right, we talk about different ways that you can handle exceptions, using the exception class's toString method and the message property, catching multiple exceptions, examining the structure of the try-parse method. We have looked at that already. Using the finally block, handling exceptions thrown from outside methods, tracing exception objects via the call stack, creating your own exception classes, and then finally rethrowing exceptions. So that's what we're going to talk about. Again, the key thing to realize, as it says on this first bullet, is an exception is any kind of error condition or unexpected behavior that comes up in a program. It can be caused by different things. It can be caused by an error in the logic. It can be caused by, and so that would be a programmer-induced exception. It can also be induced by the system itself. Possibly you're out of memory, you don't have permissions to do something that you want to do, etc. Unless you handle an exception in some way, the system will eventually handle it. And the way that typically that exceptions will be handled, if you don't handle them, is that the program will terminate. All right. There are different kinds of object-oriented techniques to manage errors like this. And as it says there, exceptions are objects of the exception class or something that's derived from the exception class. Now, here are some examples. Let's just concentrate on one of them here. All right. How about two of them? The one here and the one here. System.format exception. All right. So let's suppose that I was writing a program where I asked the user to enter in two different numbers, and the idea was once they entered in those numbers, I was going to add those two numbers up and return the two numbers. So I'm running the program, and I'm asked to enter a couple numbers. I enter 34 and 22. Boom! It comes back with 56. I enter 10 and 20. Hit enter. Boom! It comes back with 30. And I hit 40 and 50. But when I type in 50, I accidentally fat finger, and instead of typing in a 0, I type in a 0 followed by the letter P, which is right underneath it on the keyboard. Well, now what I've done is I have actually inputted something that's illegal. The system is expecting a number, and I put in something non-numeric. That should throw a system.format exception. The next one down, the system index out of range exception. Remember, if I create an array, and that array, I say has got 10 elements in it, okay? That would be elements 0 through 9. And if I'm going through and I'm writing this in a loop, maybe I want to add what's in all 10 of the array elements. So I should say basically something like for int I equals 0, I less than 10, or I less than the name of the array dot length, something like that, I plus plus. But if instead of saying I less than 10 or I less than the array name dot length, if I say less than or equal to, then what happens is the system at least tries to access 11 array elements, even though I only have 10. So I'll get one of these system.index out of range exceptions. There are other ones in here also. Here's one that would be caused literally by the system, not enough memory. All right. As mentioned here on this slide, most exceptions derive from one of three classes. Either the predefined exception class, system exception, some kind of a user-defined exception class that's derived from application exception, and the exception class itself, which is the parent of both of these. You can deliberately, as it says there, generate a system error. Now, when it says deliberately, typically you wouldn't do this on purpose, but if you were testing, you could do this. An example of this is dividing by 0. Now, different programming languages handle this differently. For instance, if I'm working in the JavaScript programming language and I attempt to divide 10 by 0, typically I'll get back an answer of infinity, which technically is the answer. All right? In a language such as C#, if I attempt to divide 10 by 0, I'm going to end up with some kind of a system exception. As it says, the program will terminate, and it'll terminate right away. And unless I handle the error, the system, as mentioned, there is unforgiving, meaning there's nothing I can do about it. All right? Object-oriented error handling techniques provide a different way, kind of a more natural, I don't know if natural is even the right word, but a way of handling it. With exception handling, you can continue when you find a problem. So you can try to handle it, and even if you can't handle it, you can cause what you want to have happen to happen. And as mentioned there, especially in mission-critical programs, it's very important that that happens. Programs that can handle exceptions appropriately are more fault-tolerant. So in other words, they're designed so that they operate even if there's some kind of a problem. They're also more robust, and as it says there, that's the degree to which a system is resilient to stress. Now, here's an example, and I know it's a little bit hard to read here, but it's a simple miles per gallon program. So it comes up here and it says, okay, enter the miles driven, and you put in 300, all right, for right there. And you convert that to an integer. Then it says enter the gallons per gas purchased. You enter 0. The error is going to be thrown on the line right here because, again, you're attempting to divide 300 by 0. So it comes back up with a system divide by 0 exception, and it says attempted to divide by 0. Now, one way that you can somewhat handle this is you could check this. So you could check to see if the denominator, the number that you're dividing by is 0. And if it is, you could refuse to allow that to take place because you know that that division would result in an exception. But as mentioned there, technically, it doesn't really handle the exception. It works if you think that that'll be done infrequently, but otherwise you should handle it by using what's called a try-catch block. So as it says, object-oriented systems handling use 3 different unique terms: try, throw, and catch. So what's going to happen, and you're going to see this already on the next slide, is what you do is you take any code, as many lines as it is, that you think could possibly cause some kind of an error condition to happen, and you put those lines of code inside of what's called a try block. All right? Then you check for different kinds of exceptions, one or more. So you try to what's called catch the exception. When you catch the exception, you handle it however you want to handle it. So you do something with it. And if you want to, although this is not mandatory, you can also put in what's called a finally block. And the finally block says whether the try works or the try doesn't work, either way, do this finally block. And we're going to go over all these in just a minute. So as it says, the try contains statements that could potentially produce an error. You must have at least one catch, or you must have a finally after the try. So here's an example. And it'll make more sense when we see an actual example with some code in it rather than just comments. All right? So you can catch one type of exception or more types of exceptions. You must code at least one catch block or a finally block. So this, you can't have a try all by itself. Typically it'll have one or more catches, but if you don't have a catch, you must have a finally right there. So here's an example. This is our miles per gallon program. And notice now we're trying to do all of our inputs and conversions, and the division. Now, if we divide by 0, we say MPG equals 0, and we say there, right line, you attempted to divide by 0. So we run it, we enter 300 for the miles driven, 12 for the gallons purchased, and we get 25. We enter 300 for the miles driven, 0 for the gas purchased, and now we get, you attempted to divide by 0, you got 0 miles per gallon. You are now taking over. The program is not breaking, so to speak. You are handling it. The exception class, as it says, it overrides the toString method. It provides a more descriptive message. There's the message right there. All right? So this is one that we put in. You attempted to divide by 0. Okay? Sometimes you also want to get whatever the system has for an error message, so you can do that as it says. You can receive precise information about any kind of exception that's thrown. And notice the difference in this. Here we didn't put in our own stuff in the parentheses after the right line. We put in E. We had an E here that we didn't use, but we have an E here, which means it's an exception object, and we use E dot to string. So we get a system message, which is more cryptic, and sometimes you might want to put your own message and the system message in there. But notice what it does tell us. It tells us the type of exception. System.divide by 0 exception. All right, then it said attempted to divide by 0. So it says there's a message property here which contains useful information about the exception and a get type. So there's all sorts of information that the system will provide for you regarding the error. What you decide you want to show the user running the program is either going to be up to you or up to the people or persons that you're reporting to. Again, you can put as many statements as necessary within a try block. The first time you generate an error, even if you've got several lines in there that are wrong, it's only the first one that throws the exception. Once you're in a try block like this, and you throw an exception, control, let's say that right here, so we put in a 0. So control right there transfers from here down to here. And you cannot jump back. There's not a go-to or something that you can use to jump back into your try block. That's not how it works. You can also handle various exceptions by the same exception block. Now, in the earlier example, we used the most generic exception there was, which is exception. The problem with that is it's not real precise, and it can be thrown for a lot of reasons. Here, notice what we're doing is we're calling a divide by 0 exception. That might be a little bit easier to understand. So in this case, we are attempting to divide 13 by 0. So it comes up and it catches the error that's right here. Even though there might be another error down there, it doesn't matter. All right? So I can put multiple catch statements in there, and they have to go from the most specific to the most general. So if I'm going to use that exception, which is the most general kind of exception that you can have, that has to be at the very bottom. But even if both of these exceptions are true, the one that'll be called first is the one that's listed first and the other one is skipped. Only one catch can literally be called. Now here's an example where the first one, all right, the first one, nothing happened because we didn't find that error, because even though it's an error, we've got a mistake. This is the line that's an error. Actually, both lines are erroneous, but it finds the first one and it says, okay, This line is an error. Is there an error, a catch statement that matches this error? Divide by 0? No. Index out of range? Yes. So it throws the code that's in there. The author's done a really nice job, I think, in this chapter of going through what's going on in here. It'd really be worth your time to read this if you want to be much more privy and much more understanding of what happens during the exception process. All right? Again, catching multiple exceptions, if you just put an exception in there, it'll catch everything. So it's poor coding style for a method to throw more than 3 or 4 different exceptions. So if you have in here, if you have catch this, catch this, catch this, catch this, if there's that many possible problems, what that means then is there's a good chance that when you wrote the code, you really could have probably written it in a better way than you wrote it. All right? All right. Unreachable code is also called dead code. So again, if it turned out that this line throws an exception, this result equal array sub num, if I never hit this line right here, that's dead code because it is never reached. Now, we've looked at try parse before. I had you do this in several, or I've done this in several of the programs. Try parse, as mentioned right here, allows the conversion of string data to another type without you having any fear of getting uncaught exceptions. So it's a cleaner way of doing this. All right? Back in Chapter 8 is when we talked about it. And I might have even talked about it before that. So here's trying to catch it using literally the try catch, which is fine. Okay? But you could also have done that same code like this. Some people consider that to be cleaner. Some people like the fact that when you use try catch like this, you can be very specific as to the error. Other people don't like it because it results in much more code. All right? As they sometimes say, the truth typically lies somewhere in between. So you typically use a combination of these. The finally block we talked about already. The finally block is always performed, whether the try totally succeeds or whether it fails and the catch happens. Now, I do want you to realize that if we look, for example, at this code right here, the idea is we go through this code, we try this. If this works and this works, if these 2 lines work, we totally skip all the catch stuff and we go down to whatever the statement is after the try, after the last catch. If either one of these fails, the system looks for a corresponding catch block. If it finds it, the first one it finds that can handle the error, then the rest of the code in the try does not execute, but the first catch that it finds executes, and anything after that, any other catches, they don't show. If you've got code in here that fails in the try block, and there is no catch that you have coded for it, or there is no catch that matches the error, the system will work its way up what's called the call stack, and we're going to see this in just a second, and eventually it will error out and the program will terminate. All right, so again, the finally block always executes, whether the try ends normally or whether it ends abnormally. So if the try works, the finally block, if you put it in there, runs. If the try fails and a catch block executes, the finally still runs. If the try fails and there's no associated catch, the finally still runs. So it always runs. It's put after the last catch statement. Only one finally. Here's an example now, albeit they've used comments here and not actual code, but it does make sense. You'd come in here and you'd attempt to open a file. Well, if the file does not exist that you're attempting to open, you'd get some kind of an I/O exception. All right? Well, what if you can open it if you attempt to read it, but you don't have permission to read it? You're going to, again, get some kind of an I/O exception. So you open it and you read it and you attempt to place the file into an array. All right? Now, if you attempt to place it in an array, you might get an I/O exception, but there's probably a better chance you're going to get some index out of range or some other kind of exception. So for example, if the file contains strings and you attempted to put it into a numeric array, you'd get a problem. So the open the file and the read the file, both of these, if you had an error, would probably be a system I/O exception. The other ones that are in here, when you're putting it into an array and calculating and displaying the average, probably wouldn't be caught by an I/O exception. Probably would be caught by some other exception that would be underneath this. But if any one of these failed, whether you caught it with an exception or not, you would always run that file. Or the finally. The finally, this is a good example because typically the finally is used. Typically, the finally is used for cleanup work. Close up any files, close up a database connection, or whatever it happens to be. An advantage of using object-oriented exception handling, as it says, you can deal with exceptions appropriately as you decide how to handle them. That's a key thing. If you don't put in your own code, the system will eventually handle them. But the way the system typically handles them, as we've discovered earlier, is by terminating the program. When methods from other classes throw exceptions, you don't have to catch them. Your program can catch them, and the advantage of doing that is you can decide what happens if those errors are caught. So here's an example right here where we're saying enter an item number. Well, you'll notice that the array has item 0, item 1, item 2, and item 3. So we say enter an item number. And we enter a 4, which is out of range. So it comes back and it writes out index was outside the bounds of the array, the price is 0. If we didn't catch this, we'd still get some kind of an error like this, but then the program would terminate. With us catching it like this, we can still write the error, but then we decide what happens next, and that's a very important concept. Here, what's happening is we give the user the error message that says you must enter a number less than 4, and we tell them to re-enter. But since the whole thing is inside of a loop, so what we've done in here is we've given them messages, and it hits here, and it says, oh, I'm in a loop. If is good item is still set to false, we try it again. All right. As you work your way, so let's look at where we had an error before, where the system has shown us an error. Where we have one. System divide by 0 exception, attempted to divide by 0. That right there, what the system is doing when it's throwing an error and it's showing us errors like that, what the system then is attempting to do is it's attempting to show us what's called the call stack. Now again, many of the programs that we've written thus far have had very few methods in them. But when you write an actual application, you could have hundreds of methods. So when you have what's called the call stack and you encounter an error, what the system does is it shows you all of the methods that were called in order that got you to that point of the error, and that's called the call stack. As it says, it's got the memory location where the computer stores a list of locations from which the system must return. If a method throws an exception and it does not catch it, the exception is thrown up to the method that called that. That's called propagating the exception. You can use the stack trace to determine exactly where the error happened. Now, they're going to show you an error in here, and the author says, don't ever do this because they're purposely making an error. They are purposely creating an error. The error is we've got an array with two elements, element 0 and element 1, and you're attempting to set up an element 2, which is illegal. All right? So they're walking through all this stuff, and the point is they're starting to show you a stack trace here. And when they show you a stack trace, they're basically saying this ran, then this ran, then this ran, then you got some kind of an error. And that's called unwinding the stack so you can see what's happening there. Now, The exception class that exists in C# is a great class in that it has a lot of different things it provides for you. That's the good news. The bad news is there's no way it can handle every exception. Let's not even look at the one that's here, because this is a kind of a tried and true one. But if we go back, I'm going to jump back for just a second. How did we start this discussion? We looked at, even further back than that, this program right here, where we told you to input a number that represented the gallons purchased. And if it was 0, okay, we were going to get an error message. We could set up our own exception that checked for a lot of different things, such as we could set up our own exception that checked for 0. We could set up our own exception that checked for a negative input. We could set up our own exception that checked for no input, so it was blank, or non-numeric input. So we can create our own exception by doing there, as it's shown, what's called extending the application exception or exception classes. So we're creating our own exception. In this case, it's called negative balance exception. So we're assuming that a bank can never have a negative balance. If it does get one, we're going to throw this error that's going to say bank balance is negative. And notice when we do this right here, this is the constructor because it's the same name, negative balance exception, the same name as the class name. All right, right here, it has no parameters, so it is a parameterless constructor, but this means that it will call the parent, the exception class, and it'll pass the message into it. So what you're going to end up getting from the exception class is bank balance is negative. And they show an example of calling that in here. Again, it's like anything else. Working with exceptions in a programming language is like anything else. You become better at it the more experience that you get with it. So the easiest way to learn any of this stuff is to start writing yourself a simple program. And if you want to write a GUI program, for example, you can do that. Put 3 labels, 3 text boxes, and a button. The first label can say enter number 1 here with a text box to the right of it. The second one can say enter number 2 here with a text box to the right of it. The third one can say answer with a text box that's read-only to the right of it. Then the button can say calculate. All right, and try to put a 10 in for the first number, a 0 in for the second number, and click calculate. And attempt to divide the first one by the second one. You're going to throw one of those errors. Then go in and handle it. This is the best way to learn anything, is to get your hands dirty, so to speak, and to go in and actually write some code. Now, it's also possible, as they mentioned in this particular example, to do what's called rethrow an exception. When you rethrow an exception, you let the calling method handle it. The method that catches it does not have to handle it. Within a catch block, you can rethrow an exception that was caught by using the keyword throw with no object after it. So here's an example right there, throw. All right. Now this was just an introduction to exception handling. As mentioned previously, the only way that you can become expert in this is practice, practice, practice. And, I don't know if this is a programmer's credo or not, but as far as the world of programming, practice does not make perfect because there is no such thing as a perfect program. And speaking as a programmer, I find that a good thing. All right. So in this chapter, we talked about the specifics of exception handling. We learned what exceptions were. We learned about the exception class. We learned some of the specific system exceptions. We differentiated between traditional error handling methods, doing things like using an if statement to make sure something doesn't happen, and object-oriented error handling methods where we use the try, catch, finally. We looked a little bit at using the exception class's toString method and its message property. We talked about catching multiple exceptions, and we mentioned that when you put in multiple catch statements, they must go from the most specific to the most general. And if you're going to put exception it has to always be at the end, just the exception. We looked at try parse. Actually, we re-examined it back from the days in Chapter 8 and earlier. We talked about the finally block and how that's thrown, whether the try succeeds and the catch is never executed, or whether something in the try fails and the catch executes, or whether the try fails and there is no catch statement, or there is no catch statement that handles that error. We talked a little bit about how to handle exceptions from outside methods, so methods that you have no control over. We looked a little bit at the stack, the program stack trace, and I talked about the fact every time you go from one routine to the other. So if I'm writing code and I've got, I ask the user twice to input values. So I've got my code that's got a write line statement that says enter a number. Then I do a read line. I've now lost control of the program. Control's gone over to the system so it can do the read line. So I put in a number. It comes back again to my code that says now enter a second number. And I do another read line. So again, every time you do that, you are calling different methods in order to be able to do it. So if I do that and then I enter a second number, and now I call a method to add those two numbers, different things have happened. So different errors can happen during different parts of that program. And what the call stack will do is it'll show me basically the code that was running when the error occurred and the code that ran previous to that. We also looked at a simple example, actually two of them. I went over one with the exception class where we talked about how we could have had our own exception for inputting gas that was either negative or zero or non-numeric. We also looked at the negative balance exception for a bank that the author put in there. And finally, the chapter ended with us talking about rethrowing exceptions. All right, in the next chapter, we will be going over the major controls. All right, we will be going over in Chapter 12, we will go over the major controls, the basic GUI controls. Now, I'm not going to spend a lot of time on that, just so you know, because unlike the way the author has done this, I have been going over most of these controls since the beginning of class. So I'm just going to highlight the controls that are in there that we have not yet talked about. All right? So I'll be back with that shortly.